Now we're going to be solving question 5. Now, you see I made a mistake, so I had to create a second video. The velocity vector is equal to the integral of the acceleration vector. Alright. When we integrate this acceleration vector, we get 2t squared 3t squared and negative sine t. And that is dotted with c, which is the vector of constants, since when you do an indefinite integral, you also have to add in a constant. Now, to solve for this c, we use these initial conditions they gave us. And when we do that, we would have 2t squared plus c1 is equal to 1 for t equals 0. And when t equals 0, this term would cancel out, and therefore c1 equals 1. Solving for the y component, we would have 3t squared plus c2 equals negative 1. Now, see, this term would cancel out again because t equals 0 and c2 equals negative 1. Finally, we would have negative sine t plus c3 equals 1. When we do that calculation with t equals 0, this term would also cancel out again because sine of 0 is equal to 0. So then c3 equals 1. Putting this all together, the velocity equation would be equal to 2t squared plus 1, which is c1, 3t squared minus 1, c2, and finally negative sine t plus 1. And that is our velocity equation. We would now have to integrate this again to find the position equation, which is the position vector, r of t. So r of t, we also know, is equal to the integral of the velocity vector. When we do this, the same process follows, that now r of t would be equal to 2/3 t cubed plus t cubed minus t, and cosine t plus t. And that would have to be dotted with, this equation would have to be dotted with I guess we have to change the variable now. The constants would now, I guess we can call it b1, b2, and b3. Alright, and now we have to solve for those constants. We have the initial condition of r0, and when we solve for those, we would get 2/3 t cubed cancels to 0 because this is at t equals 0. 2/3 t cubed plus plus 0 plus b1 equals 1. Now that everything cancels to 0 when t equals 0, so therefore b1 equals 1. Now, if we solve for the y component, we would say 0, because from up here we see that r0 is 1, 0, 0. So 0 equals t cubed, which is 0, minus t, which is also 0, plus b1, or b2, sorry, b2, the second constant. So our second constant is 0. That makes life a little easier. Now, the third component, or the third constant, would be then b3 plus what we got here, cosine t plus t. Cosine t plus t equals our z variable, or our z component, which is 0. When we find that, we would know that cosine of 0 equals 1. So b3 plus 1 plus 0 equals 0. So therefore, solving for b3 equals negative 1. So now to plug it into our vector equation here of the position, we would see that r of t is equal to 2/3 t cubed plus t plus b1, which is equal to 1, comma, t cubed minus t, and the b2 is equal to 0, so that's all we have there. And then the third component would be cosine t plus t minus 1. And that is the end of the vector equation. This, if I had enough space, I would have written it here, but I ran out of space due to this large font I'm writing in. So the position vector would be equal to 2/3 t cubed plus t plus 1, comma, t cubed minus t, comma, cosine t plus t minus 1. And that's how you find the solutions to number 5. All right, that was a very tricky problem, even with the solution right next to me. All right, so now number 6, we are asked to find the unit tangent vector, the unit normal vector, and the unit binormal vector of the space curve listed here. And we're supposed to find this at the value t equals pi over 2. All right, so I wrote t of pi over 2, n of pi over 2, b of pi over 2. All right. We know that the unit tangent vector is equal to the derivative of the curve over the magnitude of the derivative of the curve. When we would write this out, we would get, for the derivative, 2t, comma, cosine t plus t sine t, comma, and t cosine t. And that is the numerator. The denominator is the magnitude of the square of this, which would equal 4t squared plus cosine squared t plus 2t cosine t sine t plus t squared sine squared t. And if I had more room, I would write out the entire denominator. But luckily, when you plug in the t value of pi over 2, a lot of these actually cancel out. And what you're left with on the bottom, when you plug in for t of pi over 2, you get, for the numerator, pi, because pi over 2 times 2 is just pi, comma, 1, because cosine of pi over 2 is equal to 0, sine of pi over 2 is equal to 1, and this will be multiplied by pi over 2. So this is actually not 1. This is actually equal to pi over 2. And the final value is t cosine t, which is equal to pi over 2 times cosine of pi over 2. But cosine of pi over 2 is equal to 0. Therefore, the z component would just be 0. When you plug in t equal to pi over 2 for the magnitude, you would then get pi squared plus pi over 4 plus 1. And this can be rewritten as the 1 over this magnitude, which is pi squared plus pi over 4 plus 1, times the vector pi over 2, 0. All right. Now we're going to find the unit normal vector. The unit normal vector is equal to the derivative of the tangent, unit tangent vector, we'll say of t for now, over the magnitude of the unit tangent derivative of the unit tangent vector. When we take the derivative of the unit tangent vector, we would get 2 t cosine t and cosine t minus t sine t. All right, and that is the numerator of the unit normal vector. Now, the magnitude of this would also be a very messy equation, but I'll write it out. 4 plus t squared cosine squared t minus 2t sine t cosine t plus t squared sine squared t. All right, and that's the magnitude. Now we need to find this unit normal at pi over 2. When we plug in pi over 2 for t, we would get, for the numerator, just simply 2 0, because cosine of pi over 2 is equal to 0. So 0 for the second component. And for the third component, we would get, that cancels out, and it would be negative pi over 2 times 1. So negative pi over 2. And that's the numerator. The denominator, when we plug in pi over 2, we would get 4 plus pi over 4 plus 1. Alright, and that also can be rewritten as 1 over square root of 4 plus pi over 4 plus 1 times the vector 2, 0, negative pi over 2. Alright, now when we're finding the unit binormal vector, which we call b, we say that that is equal to the cross product of t, is very important which order you do this in, t, unit tangent vector, crossed with the unit normal vector. When you do this determinant, which is how you take a cross product, you would get, subbing in for pi over 2, you would get pi 1 pi over 2, and that's multiplied by these two magnitudes for both n and t, which when I combine those together so that I can factor it out of the determinant, I get 1 over square root of 6 plus pi over 2 plus pi squared. All right. Now, anyways, this is the unit tangent vector. The unit normal vector would be 2, 0, negative pi over 2. When we solve this determinant, we would get 1 times negative pi over 2 minus 0. So negative pi over 2. Pi times negative pi over 2. Negative pi squared over 2 minus 2 pi over squared. Okay, so let's just write that out. Negative pi squared over 2 minus, and this is all times negative 1 because it's the j component. Negative pi squared over 2 minus 2 pi over 2. And then for the k component, which I'll have to write down here, it would be 0 minus 2, which is negative 2. And that is all multiplied by, not dot product, is multiplied by this magnitude which we factored out. 1 over root 6 plus pi over 2 plus pi squared. Okay. So that, let me write that a little neater. Our binormal vector at pi over 2 is equal to the quantity 1 over root 6 plus pi over 2 plus pi squared times the vector negative pi over 2. And then if I'm going to multiply this out and combine them, I would get pi over 2 plus 2 pi, or pi squared plus 2 pi over 2. And the final component would just be negative 2. And therefore we have our unit binormal, our unit normal vector as well, which I just crossed a line through, but I will say that that is 1 over root 4 plus pi over 4 plus 1, all right, times this vector. And we also have the unit tangent vector, which is equal to 1 over pi squared plus pi over 4 plus 1, all under the square root, times pi, comma, pi over 2, comma, 0. And that is